Hello. So this question is from GATE 2021 and this question is from the domain of mathematical physics. The question states P and Q are two Hermitian matrices and there exists a matrix R which diagonalizes both of them such that RP R inverse equals S1 and RQ R inverse equals S2, where S1 and S2 are diagonal matrices. The correct statements is or are. So option A is all the elements of both matrices S1 and S2 are real. Then B is the matrix PQ can have complex eigenvalues. C, the matrix QP can have complex eigenvalues. And D, the matrices P and Q commute. So let us solve this problem. So given that P and Q are both Hermitian matrices. So that means P dagger equals to P and Q dagger equals to Q. Okay. Now R is a matrix which diagonalizes both of them, and given is 1 equals to R P R inverse and S2 equals R Q R inverse. Okay. Where S1 and S2 are diagonal matrices, gonal matrices of P and Q. Right? So this much information is already given. Now, as P and Q are Hermitian matrices, their eigenvalues are always real. Okay, and hence the diagonal matrix will also have real elements. Okay. Is I think the first option, all the elements of both matrices S1 and S2 are real. Okay. Now we have S1 equals to R P R inverse. So let us operate R inverse from the left hand side and R on the right hand side. Then what will we get? Then we will see R inverse SR equals to R inverse R P R inverse R. Now both this R inverse R should be identity as per the properties. So this will mean P equals to R inverse S R. Okay. Sorry, this should be S1R here. And similarly, Q should be R inverse S2R. So now if we take the product, now PQ should be R inverse S1R times R inverse S2R, which means it is R inverse would be identity, so R inverse S1 S2R. Okay. Similarly, QP should be R inverse S2R, then P is R inverse S1R. So this will give me R inverse S2 S1R. Okay, now as P and Q are both simultaneously diagonal, so S1 and S2 are commuting. Matrices. Okay, so hence S1 S2 should be equal to S2 S1. So QP should be R inverse S2 S1R, that is R inverse S1 S2R, which is equals to PQ. And this implies PQ equals to QP, or these two matrices commute. P and Q commute. Okay. Now again, so we have checked two of the options. Now PQ and QP are complex eigenvalues. Now we have seen that now PQ equals to QP equals to R inverse S1 S2 R. Okay, and S1 S2 is a diagonal matrix of this PQ or QP, PQ and QP. Okay, this implies that S1 S2 have real elements and this implies PQ and QP have real eigenvalues. So let us cross check the question. So option A here is correct, that both the S1 and S2 matrices are real. So option B is incorrect. The matrix PQ have real eigenvalues. So that option C, the matrix QP will also have real eigenvalues, and option D will also be correct, that the matrices P and Q commute. So this is the solution of this question. Thank you for your attention.